Hey everyone, I'm Izzy, and I'm doing my mammalian fair project on bottlenose dolphin vocalization frequencies and how they changed due to COVID. So I wanted to look at how the bottlenose dolphin call changes in regard to a decrease in boating activity. With COVID-19 happening, there's a lot less boating activity due to restricted movement of humans. My hypothesis is that in the presence of boats, bottlenose dolphins will have lower frequency vocalization calls. This is because boat noise is quite high in frequency, and to be able to be heard over that, dolphins hypothetically need to lower their frequency for communication to compete in a polluted marine soundscape. Therefore, this year during COVID-19, bottlenose dolphins will likely have a higher frequency in their vocalization. For this project, I'm using some of Professor May Collato's data collected in Boca del Toro, Panama. I analyzed different sound recordings through the program Raven, mostly by looking at the spectrogram of the sound recording. With the spectrogram up, I then selected a bottlenose dolphin call when I came across them in the dataset, as seen by this little selection box in my example image. After selecting the dolphin call, I noted the lowest and the highest frequency emitted in that selection. I collected 57 data points for each year, 2018, which is the pre-COVID year, and 2020, which is during COVID. This first figure I have kind of summarizes all of my data that I collected. It shows the average low and high frequency bottlenose dolphin calls in each year. As you can see, there's a much larger range in frequency for the COVID year, and it also is much higher in frequency in general. I wanted to further analyze the difference in the average frequency per year and also the average range of frequency within each call. Figure 2 shows the average frequency of a bottlenose dolphin call in regard to each year. So in 2018, the average frequency is about 5,300 kilohertz, while in 2020 it is nearly double at almost 10,000 kilohertz. I ran a t-test analysis to see if there was a significant difference, and there is indeed one. The p-value was incredibly small at less than 0.001%. I did the same thing for the range in 2020 compared to 2018. I ran another t-test, and again, the p-value was very small, less than 0.001. These analyses have given evidence that bottlenose dolphins have had to decrease the frequency of their vocalizations and calls due to boat pollution and likely other noise pollution in the area as well. Not only are they lower in frequency, they have a much smaller range as well. Sound pollution in the ocean is a huge problem. It can be a huge threat to marine life. Sound travels vast distances and it completely covers calls that animals use to communicate. These calls could be about prey, predators, maybe animals trying to find mates for reproduction. Really loud sounds such as sonar and noise coming from large vessels like cargo ships can be deathly or severely traumatic to marine animals. As seen in my analyses on boating traffic in Boca del Toro, dolphins significantly change the frequency and range for which they communicate in regard to the boats. I think that more has to be looked into on the effects that this has on the species, on whether it significantly inhibits their vocal communication to the point where mating and reproduction calls cannot be heard, or if groups of dolphins have trouble finding food or sharing food resources due to not being able to hear each other. Being able to hear calls is especially important between mothers and their calves as they are constantly communicating. So I think that high levels of boating could potentially be dangerous. Thanks for listening. I hope you enjoyed learning a little about the effects that boating noise has on bottlenose dolphin communication, and this has increased your awareness on the effects that sound pollution has in the marine landscape.